One really good example of when you want to modify a machine learning protocol is with a recent paper we did called Medical Dead Ends. And so the idea here is, in a standard kind of machine learning called reinforcement learning, that's really, really powerful for learning games or self-driving cars. What you do is you have many, many example demonstrations of something you want a model to learn. Many chess games, many Go games, many poker games, or many examples of people driving cars. And then you say, you as a model, I want you to learn how to do this because you have a lot of expert, or maybe non-expert demonstrations of how to do it well. The problem in medicine is we're in a really different setting. When you train a self-driving car, you can then let that model go off into a parking lot and try to drive the car for a little bit. Or if we're talking about two chess models, they can just play each other as many times as they want. And it doesn't matter if they do really poorly initially or lose a lot of games. But if we trained a model using expert demonstrations of how to treat patients in the hospital, and then it went off and tried different things and killed some patients along this learning process, we would not be very happy. So this is a very different situation. We're in an offline setting where we can't really support the machine trying to learn online in practice. And so we have a different way of thinking about the kinds of recommendations that a model can make in those settings. And we call this medical dead ends. What that means is, instead of trying to figure out what kind of recommendation a model should give to a doctor at a specific point in time for different kinds of care, we learn what actions seem to lead to bad outcomes in past iterations of clinical care, like ones for this specific patient. And by flipping the paradigm and saying we have two different neural models looking at the risk of certain treatments and the reward of the same treatment in different patients we've observed over time, we're able to give a good prediction to a doctor as they're looking at this sort of sequence of operations in real time for a patient of which treatments maybe they should avoid because they seem to be more high risk than reward.